Assalamu alaikum and hello everyone. I hope you're all doing well. Today's session will cover the topic of bases and alkalis. So let's get started and don't forget we are aiming for the stars. So bases are bitter in taste. Remember this. They are bitter in taste. They are soapy to touch and they turn the red litmus paper to blue. And bases always give solutions with a pH greater than 7. So these are a few points that you should know about bases, that they are bitter in taste, they are soapy in touch, and they turn the red litmus paper blue. Remember, I told you in the previous session that base, blue, B for blue and B for base. So they give solutions with a pH greater than 7. Now, the other thing that you need to know is that base has a metal. Okay. Now, these metals, could be metal oxides. Bases are metal oxides, or they are metal hydroxides. Okay, don't get confused. So bases are metal oxides or metal hydroxides. Metals are those, I'm sure you know what's a metal. A metal is something which loses electrons. They always lose electrons. Let's take an example. Let's take sodium. Sodium has an atomic mass of 11. So in the first shell, there will be 2 electrons. If you see the electronic configuration, the first shell will have 2 electrons, second shell 8, and then 1. Now, to become stable, an element needs to have octet. That is, it needs to have 8 electrons in the outermost shell. Now, what is easy for an element? To lose 1 electron or to gain 7 electrons? It's easy to lose 1, right? So metals, this is common for all metals. They always lose electrons. Now, where do they lose these electrons? Now, taking a base. If you take a base, so these, like if this is a metal, they lose 1 electron. So because they lose an electron, which is a negative charge, they become positive. Okay. So this is an electron which is lost. So because they have lost a negative electron, they have become positive. And now oxygen gains that electron. Okay. Now oxygen gains that electron. Now it's gained a negative charge. So it becomes negative. And this is how, okay, let's put it here because usually we don't put it this way. Okay. So, okay. So here you go. These are the electrons that is being given and taken. So lost and gained. So likewise, you have metal hydroxides. So you have metal hydroxides. So this is how the bases are formed. And I'm sure you know a few bases now. You can give examples of a few bases like sodium hydroxide, potassium hydroxide, calcium hydroxide, lithium hydroxide. Okay, and oxides. Let's take a few oxides like copper oxide, magnesium oxide, and calcium oxide. Now, so these are the bases. Okay, they could be, so or they are metal oxides. Bases are metal oxides, or they are metal hydroxides. Okay, now when we, okay, let me put it this way so that it becomes a little easy for you. So bases are either metal oxides or metal hydroxides. Okay. So bases are either metal oxides or metal hydroxides. Now, if you take metal hydroxides, A few of them are soluble in water and the others are insoluble in water. And all the bases, see all the bases that is the bases that are metal hydroxides, which are soluble in water, are called alkalis. Now, what are the ones which are insoluble in water called? They are called just insoluble bases. They don't have a specific name. Okay, so all alkalis are bases. Remember, all alkalis are bases. But all bases are not alkalis. Okay, not alkalis. I think you would be able to answer this question if they ask you in the examination, explain the statement. So all alkalis are bases because alkalis are derived from bases, but all bases are not alkalis because there are metal oxides which are not alkalis. There are metal hydroxides which are insoluble in water, which are not alkalis. Okay, so now let's see what are the ones which are alkalis. Specifically speaking, all alkalis, they are group 1 hydroxides. Group 1 hydroxides. Like, for example, NaOH. So these are all group 1 metals, right? So NaOH, KOH, so potassium hydroxide, sodium hydroxide, so all that which are in group 1 are alkalis. And the other thing is group 2. If you see in the periodic table, so this is our periodic table. In our periodic table, the last 4 elements, these calcium, strontium, barium, and radium. So these 4 are alkalis, not the above, not beryllium and magnesium. They are not alkalis. So let's put it here. So in group 2, so you can call this as classification of alkalis. So group 2 hydroxides, you have the last 4 elements which are alkalis. Make sure to write all of this down in your notebooks so that you can get back to it while you are revising for your exam or your tests. So the last 4 elements are alkalis. And another special alkali is ammonium hydroxide. Ammonium hydroxide. This is also called aqueous ammonia. It's also called aqueous ammonia. Okay, so this is the classification of an alkali. Now remember that the solution, an alkaline solution, okay, an alkaline solution will contain an excess of hydroxide ions. I think this must be clear by now. So they contain excess of hydroxide ions. And if an alkali is added to an acid, what do you think would happen? All these hydroxide ions will equate. So what does an acid have? Acid has hydrogen ions, right? So all the hydroxide ions in an alkali will equate to the hydrogen ions in an acid. Or in other words, the hydroxide ions, the hydroxide ions will neutralize. Now that's a new word which is important in this chapter. So it will neutralize the acid's excess hydrogen ions. So alkali has hydroxide ions, and if you're going to add this alkali to the acid which has hydrogen ions, it will neutralize the excess hydrogen ions. So this neutralization reaction between an acid and an alkali can be represented by an equation. Okay, so let's write the equation for neutralization. And when they neutralize, what is that? Now let's see. H plus, okay? H plus, that is the hydrogen ions, when they react with hydroxide ions, they produce an amazing liquid called water. An amazing liquid. So all bases, whether soluble or not, they will neutralize acids. So this is another important, a very important point that you should know, that all bases will neutralize acids. So that means they will neutralize acids. So whether they are soluble or not, so all bases, whether they are metal hydroxides or metal hydroxides, which are soluble or insoluble, they will neutralize acids. Done? Clear enough? So the soluble alkalis are very small parts. See, they're just a very, very small part. Small part of a very big group. Okay, so the oxides and hydroxides of metals all neutralize acids. So this must be a very clear thing that you need to understand. This is neutralization reaction. So what is a neutralization reaction? It's a chemical reaction between an acid and a base to produce a salt and water only. So we already saw this. We already saw the equation, okay, between hydrogen ions and hydroxide ions. This is a neutralization reaction. It is summarized by this ionic equation, and the general equation is this. This is the general equation. Acid and base will give you salt and water. So this is something which you have to learn. Have you heard of hydrochloric acid in our stomach? I'm sure in biology, if you had taken the subject, you must have learned that our stomachs contain, the stomach wall, the stomach wall, it produces, the cells of the stomach wall, they produce an acid called HCl, hydrochloric acid. This acid is actually produced to create a medium, an acidic medium for the enzyme. Now, which enzyme? Protease. Protease enzymes like pepsin, which actually break down proteins. So to give an acidic medium, this HCl is produced. And, however, excess acids can cause indigestion, which can be painful and eventually give rise to ulcers. I'm sure you must have heard of acid reflux. Now, acid reflux can cause ulcers even in the mouth. Okay, so to ease this, we can take an antacid treatment. Antacid. Okay, antacid treatment. So what are antacids? They are a group of bases. So antacids, they are a group of bases, and they for example, such as magnesium hydroxide. Inshallah, we will be learning more about it when we talk about the properties and uses of bases. So magnesium hydroxides or carbonates, when they are taken in, they are a group of bases, and they don't have a toxic effect on the body, and they can neutralize the body. They can actually neutralize the body. I'll take this off because we will learn more about it in a few moments. Now, let's look at a few properties and uses of these alkalis. And as we saw earlier, alkalis feel soapy to the skin, isn't it? Like alkalis, they react with the oils in our skin into soap. So they are used as degreasing agents because they convert oil and grease into soluble soaps, which can be washed away easily. And the common uses of some alkalis and bases are what we are going to see now. But before that, apart from the neutralization reaction with acids, it also reacts with ammonium salts. So here you go, the ammonium salts. Okay. So apart from neutralization reactions, remember we saw this as one, the alkalis which are classified into a special kind of an alkali. So what was that? A special kind of an alkali? Ammonium, ammonium hydroxide, or it's also called aqueous ammonia. Okay, so let's get back. Yeah. So in addition to neutralization reaction, so neutralization reaction is this. Okay, when there is water produced, along with the salt. So apart from that, acids, ammonium salts, they actually react with ammonia, bases react with ammonium salts to produce ammonia gas. They produce ammonia gas. So here I have a reaction for you all. Okay. So here you have ammonium nitrate. It reacts with sodium hydroxide to give you sodium nitrate, water, and ammonia. So this reaction occurs because ammonia is more volatile. Now, what's volatile? It is it can easily evaporate. So this is a volatile base than sodium hydroxide, So ammonia is therefore easily displaced from its salts by sodium hydroxide. And the reaction can be used to test an unknown substance for ammonium ions. So you will be learning about it in the later chapter as to how the tests need to be done. For now, we will kind of, try to do this test, ammonia. How is ammonia gas detected? So again, whenever you put the litmus paper through ammonia gas, it turns blue. So it is the same as base. Remember what we learned? We learned that base, whenever a base is run through a litmus paper, the red litmus paper turns blue. So the same thing happens for ammonia gas. A base such as calcium oxide or calcium hydroxide, okay, can be used to prepare ammonia, in the laboratory. But when these two solids are mixed together, ammonium nitrate and calcium oxide, when they are heated together, you have ammonia produced. Now you might be wondering, why is ammonia so important? Yes, ammonia is important because ammonia is the requirement. It is used in industries to make fertilizers. And here you have, in the petroleum industry, agricultural industry, to make leather, rubber, food and beverage. So all these are the uses of ammonia. Let's look at a few alkalis and its uses. We have sodium hydroxide. It is called caustic soda. So here you go. So this is caustic soda. And where is it used? It's used as in oven cleaners, degreasing agents, in making soap and paper, other industrial uses. These are all the uses that you can see. So caustic soda, what is its formula? Its formula is NaOH, sodium hydroxide. So sodium hydroxide is also called caustic soda. And of course, it is a very strong alkali. It's a strong alkali. It's a strong one. Okay. And then we have potassium hydroxide. Now, what is potassium hydroxide called? It is caustic potash. Okay, here the name is not given, but potassium hydroxide is called caustic potash. It's called caustic potash. As we know that NaOH is called caustic soda. Caustic potash is potassium hydroxide. And what is its formula? Its formula is KOH. And it is also a very strong alkali. It is also used, in biodiesel. Can you see this? They are used in biodiesel production. You have liquid soap and as agricultural fertilizer and battery production. So these are a few uses of alkalis. Now, then we have calcium hydroxide. Calcium hydroxide is CaOH twice. So this is generally called, a common name is lime water. It's lime water, and it is also a very strong alkali. So these are a few alkalis that you should know by heart. So here, this calcium hydroxide, it neutralizes soil acidity and acidic gases produced by power station. So these are a few. Here you see calcium hydroxide. Okay, let me just push this up a little to show you these pictures. So calcium hydroxide, they are used in the construction industry. They are used for treatment of water and, of course, chemical manufacturing. So if you talk about the bases, the other bases, okay? So if you see calcium oxide is one, and you have magnesium oxide. So you have calcium oxide and magnesium oxide. So where is calcium oxide used? Again, calcium oxide, it's used in to make cement and concrete blocks. And not only that, it is also used to neutralize soil acidity, industrial waste products, okay, making cement and concrete. And when we talk about magnesium oxide, it is used as an antacid in indigestion tablets. Okay, so these are a few uses. This could be a question that can be asked. It's a potential question, examination wise. So become a little familiar with the. Okay, now before we wind up today's class, I want you to do a small activity. Pause your video and circle all the bases. Circle all the bases that I. You pause your video because only then you will be able to do it. Okay, so what are the bases here? So calcium oxide is a base, lithium oxide is a base because they are metal oxides, ferrous hydroxide, copper hydroxide, lithium hydroxide, barium hydroxide, magnesium hydroxide, aluminum oxide, calcium hydroxide, and potassium hydroxide. So all of these are bases. Now, can you tell me which are the ones which are alkalis here? You can kind of put a tick to it. So pause your video and do it right away. Fine. So here you go. Now, is ferrous hydroxide an alkali? No, it's not an alkali. Because remember the classification that I had given you. All the group 1 hydroxides are alkalis. The last four in the periodic table of group 2 are alkalis. So ferrous does not belong to group 1 or group 2. So it is not an alkali. Lithium oxide, is it an alkali? Although it is the element belonging to group 1? No, it's all alkalis. Alkalis need to have hydroxide in them. So this is also not an alkali. Copper, no. Copper oxide, no. Lithium hydroxide, yes, this is an alkali. Barium hydroxide, let's check the periodic table. Okay, so let's check the periodic table. Do I have my periodic table here? Yeah. So here you go. The last four of group 2 are alkalis: calcium, strontium, barium, and radium. Yes, barium is an alkali. So this is an alkali. Magnesium oxide, no. Aluminum oxide, no. Oxides are not alkalis. Calcium hydroxide, yes. Calcium hydroxide. So if you want, check it up in your periodic table. So calcium hydroxide is an alkali. So let's tick it. Now, what about carbon dioxide? What about carbon dioxide? Carbon dioxide is not a base. Why? Because it's a non-metal. It's a non-metal. So it's not a base. Remember, only metal oxides and metal hydroxides are bases. Okay, after this small activity, I want you to answer these questions. So let's see if you can answer these questions. What's the formula of sulfuric acid, hydrochloric acid? Again, pause the video and answer these questions. Try to answer all these questions. And after you have answered them, do check your answers. So these are the answers for these questions. So do make sure to check your answers. Thank you for watching. And in our next video, we'll cover metal oxides and non-metal oxides. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.